Ever since I joined Dygma, I've tried many ergonomic keyboards. However, most of those keyboards are what's called pre-built, like the Dygma Defy, meaning that everything is assembled and configured, and you just have to plug them in. They also come with a visual configuration software, which makes it fairly easy to customize your layout, add layers, and whatnot. In the case of the Dygma keyboards, that's Bazecor. But if you ask an ergonomic keyboard enthusiast for recommendations, they will most likely tell you to get a DIY keyboard, like the Shuffle, the Corne, the Kyria, or the Lily 58. The reasons: they are usually cheaper, there are far more options to choose from, you can customize it to your liking, and the configuration options for the firmware are almost infinite. Seems like keyboard nirvana, so I had to try one out. Hi, I'm Michael Kirby, and today I'm going to tell you about my love-hate relationship with DIY QMK keyboards. Let's start from the top. Buying the keyboard. I had a relatively good idea of the keyboard that I want. It had to have a 3x6 split layout. That's 6 columns and 3 rows per side. That's significantly less than what my daily keyboard, the Defy, has. But with time, I have been using fewer and fewer keys to reduce hand movement, so I wanted to try a smaller keyboard without the number rule. It also needed to have at least 3 thumb keys. Having tried the CSA Voyager, which only has 2, I knew I needed at least 3. I would miss some of the extra thumb keys on my Defy, but I imagined I could work around that limitation. I also wanted it to be low profile. Since most DIY keyboards don't have palm rests and palm pads like the Dygma Defy, I wanted something as thin as possible. Another important feature is that I wanted it to be wired. This was my first incursion into DIY keyboards, and I didn't want to feel overwhelmed. Finally, I wanted a pre-soldered PCB. I knew this would make the keyboard more expensive, but I don't know how to solder, and the project was already daunting enough. After a lot of surfing, and I mean a lot, I ended up getting the Boardsource Unicorne low profile. It uses a powerful RP2040 chip, has USB-C connections all around when other boards use TTRS cables to connect the sides, and has a beautiful CNC aluminum case. Or aluminum, we never know. It costs $215 without cables, switches, or keycaps. I had my own, but if you had to get those, you'd be looking at about $300 total. And that's for a keyboard that you must assemble yourself, comes without any extras, and has no official support for software or firmware. To put into perspective, the Dygma Defy and the Dygma Race 2 start at $369 and come with many goodies, including a travel case, pal pads, and an enhancement kit. And of course, you get software support to help you configure your keyboard to your liking. With the Unicorn, I will have to rely on the community, searching on Google, or maybe asking ChatGPT, which makes everything a bit more complicated. Truth be told, I could have gone a cheaper route though. If I knew how to solder, I could get a PCB Corn kit for around $80 or even less. I would also need a 3D printed case, which can cost around $30, switches, another $30, and keycaps, which can range from $20 to $50. So the final cost would be something like $160 or $180. Less if you have some of the parts already, or if you could 3D print the case yourself. However, if I went that route, I'm sure this video wouldn't be out yet, because I would have irreversibly damaged the PCB, or even worse, I would have burned the Dygma office down. Oops. Now it's time to put everything together. The good thing about a pre-soldered kit is that it's super easy to assemble. Just place the PCB in the base, screw the top plate, insert the switches, put the keycaps, and you're good to go. If I had gone with a PCB kit, I'd have to spend a few hours soldering the sockets, the diodes, the LEDs, and the microcontrollers. We've shared a few videos in the description if you want to see how that looks, but it's definitely not noob friendly. And now, buckle up for the fun part, configuring the keyboard. The Unicorn comes with a VIA-compatible QMK firmware installed. Configuring the keyboard with VIA is very easy. Connect it to your computer, open VIA on your browser, make the changes you want, and they will be saved to your keyboard immediately. This is very similar to configuring a Dygma keyboard. You open Bazecor, our configurator software, make the changes you want, and press save. My end goal here is to recreate my Dygma DeFi configuration, which consists of a base layer with my custom engram layout, a navigation layer, a symbols layer, a number pad layer, and a layer with different macros. Let's start with something easy and rearrange the keys to match my base engram layer. As some of you might know, I cannot type QWERTY on a columnar keyboard, even if my life depended on it. Check out this other video if you want to know why. Here it is, but I've encountered a few issues. First, not all my keys do what I programmed them to do. For example, my apostrophe outputs a dash, and my asterisk a parenthesis. Fortunately, I know why. My computer's input language is Spanish, and VIA uses the standard ANSI US layout. Everything would match if I change my input language to English US, but I don't want to do that. I want my AE. The workaround is to figure out which keys in the English US layout are in the same position as the ones I want in the Spanish layout. If I want to get the apostrophe, I need to place the key with the dash. And if I want the asterisk, I need to place the key with the closing parentheses. Confusing, right? Now that I've done these changes, the keys output what I want, even though the layout on VIA says something else. It's confusing, but I can work with that. This is much easier on the Dygma boards, as we provide keymaps for many common input languages. That way, what you see in the configurator software will match what the key outputs. However, there is another much bigger issue. On my Dygma DeFi, I use what's called mod tabs and layer tabs on my Thumbkeys. We call them add a key on tab. That's when a key does one thing when you hold it, say shift or a layer change, and another when you tap it. For example, backspace, space, or enter. Navigating through all the options in VIA, I could only find how to do that with space on tap and layers 1 to 3 on hold, and for modifiers on hold and parentheses on tap, nothing else. And that's a key feature, especially on a small keyboard with fewer keys and only 3 thumb keys. You need to get the most out of the keys that you have. Much later, I found that there is a workaround for this in VIA. There is an any option under the special keys submenu. There, you can input any QMK keycode, including mod tabs and layer tabs. But at the moment, I didn't even know those keycodes existed, and they are fairly complicated if you are new to QMK. So I tried the next tool I knew, QMK Configurator. QMK Configurator lets you configure many more things about your keyboard. To start remapping your keys, select your keyboard model in the menu above, and that's it. Here I have all the mod and layer tabs that I need. The issue with the Spanish-specific keys is still present, and I can't import the keymap from VIA, but who cares? Not that I had remapped much so far. Before completely setting up all my layers, let's test the base layer. With the QMK configurator, changes are not saved directly to your keyboard. You must compile it and then flash it. To compile it, press Compile and wait for the potato to bake. It might take a while, so now is a good time to grab a coffee or any other beverage. Thank you, Anna. Once that's done, you download it and flash it to your keyboard. But wait, how do you flash it to your keyboard? After more googling than I'm willing to admit, I discovered how to do that for my keyboard. You disconnect the keyboard, you press the top left key and hold it while you connect the keyboard to the computer. A drive will open on your computer, and then you drag the file that you just downloaded to that drive. The keyboard will wake up with the configuration that you just set up. Then you repeat the same thing with the right side of the keyboard. But beware, on that side you need to press the top right corner because it's symmetrical. Done. Wait, why is my cursor driving through the screen? Where are you going?
A few moments later.
After a bit more googling, it turns out that on some systems, users may face an issue where their mouse cursor will drift after the keyboard is plugged in. To eliminate this issue, you simply need to tweak the code in info.json. Right, but where is that info.json? I can't change that in the QMK configurator. So, if I download the whole source code instead of the compiled firmware, I can find that file under Keyboards, Boardsource Unicorne. Although, to make it a little bit more confusing, it's called keyboard.json and not info.json. I can open that file with a text editor and change pointing device true to pointing device false as per the instructions. Yay! Oh, wait a moment. And now, how do I put this into my keyboard?
2,000 years later.
It turns out I need to compile the firmware myself. Yay! On my Mac, I only need to install Homebrew. Let's fast forward this because it's a bit tedious. Then open the terminal to install QMK. And set it up. The link to the documentation on how to do this is in the description below. Once you've done that, you can run the command qmk compile -kb, your keyboard, -km default. For my keyboard, that's qmk compile -kb boardsource /unicorne -km default. Once the firmware is compiled, I have to put each side into bootloader mode again and drag the files to the new drive, just like I did before. Awesome! My mouse doesn't drift anymore, but now, every time I want to make changes to my layout, I have to upload it to QMK Configurator, make the changes, download the layout, replace the keymap file in my QMK folder, compile the firmware with the terminal, put each half into bootloader mode by plugging it in while holding escape, and drag the file to the new drive. It's tiring just to say it, and it only works if the computer has the environment set up. It's far more complicated than Vial or what I'm accustomed to with Bazecor. Open the app, make the changes, press save, and boom, the changes are saved. There must be an easier way. Back to Google!
One eternity later.
So instead of using QMK, I can flash my keyboard with a fork of QMK with Vial specific features. Is it Vial or Vial? Vial is very similar to Vial in the sense that you can make live changes to your keyboard with a user interface and without having to compile anything. But it has more advanced features similar to QMK Configurator. The documentation on how to set up Vial QMK is not as good as normal QMK, so I had to ask my imaginary friend ChatGPT. After a few terminal prompts and a compiling error due to some missing dependencies, I got the Vial QMK firmware on my keyboard. Phew! The nice thing about Vial is that you can use either the web app or the desktop app. You can also choose among different languages, including Spanish. Ole! So I can finally assign my keys without looking for the equivalent in English US. Finally, I have my ñ back. The drawback with Vial is that it's a fork of QMK, so it's less frequently updated, and not all keyboards are supported, so make sure yours is beforehand. But most importantly, Vial lacks one key feature for me: per key RGB. I want each key on each layer to be a different color, like on my Dygma D5. Even though I don't look down at the keyboard a lot, this is really helpful for getting your bearings when learning a new layer, or just giving you a visual indication of what layer you're on. With Vial, you can configure basic LED effects, but not per key RGB. You have to code that yourself, or myself. So I'm back to square one. Again! I now have to edit my keymap with a text editor and figure out how to program per key RGB. Let's start with the first task. To modify my layout, I have to locate the keymap.json within my QMK folder and open it with a text editor like Visual Studio Code or Cursor. My keyboard is under Boardsource Unicorne Keymaps default. But if you have a different keyboard, you'll have to find yours. And there are a lot. You might want to make a copy of that folder in case you mess things up, which you will. I'm going to name my copy Dygma, but don't go revealing my secret identity to anyone. Now the fun begins. Each key has a different code in QMK. You only need to find the code for the key that you want and type it in the position of the keyboard you want to place it. You can tabulate the code to resemble the keyboard's layout and make it easier. But at first, you'll spend a lot of time in the QMK documentation learning each key code. The standard keys are relatively easy. For example, A is KC_A. But things get more complex with other keys, such as punctuation marks or modifiers. And if you want to do more complex stuff, like modify keys, mod tabs, or layer tabs, you are in for a treat of reading documentation. But do you know what's the most fun about it? You will get a compilation error if you mistype any of the keycodes. And given how complex some of them get, I can assure you, you will get a lot of compilation errors. In addition, if you use a different input language than English, you must configure it to use the language-specific keycodes. When I tried to configure this for the first time, the documentation said it was as easy as adding #include Spanish.h at the header of my keymap. But I kept getting a compiler error. Why? It turned out that this only works on keymaps written in C, as in keymap.c instead of keymap.json. So I went a little bit crazy trying to find out how to migrate my layout to C. After quite some research, I found a keymap for a Corn keyboard, which has the same layout as the Unicorn, and the #include worked immediately. Now, I only had to rewrite the layout in C again, but by this time I knew most of the keycodes by heart. I only had to learn the Spanish-specific ones, which you have to find within the source code. If you feel like I'm getting irritated, it's because I am. Much later, I discovered that you can also do that in JSON by adding host language to your keymap settings. This was elsewhere in the documentation, which has been updated since and now reflects both methods. So after many compilation errors and headaches, I now have a working layout. Except I'm missing a key thing, macros, and I haven't forgotten about per key RGB, one thing at a time. Macros are their own beast when programming them in C. They are explained in the documentation, of course, but there's a lot of trial and error coming your way. The easy part is to first name the macros as custom keycodes. Just make sure you don't use any predefined keycodes. You use these custom keycodes to assign the macros in your layout. Then there's a bit of code to define what the macro does. You can send normal text, which is case sensitive, SS tab, which sends a key tap, SS down, which sends a key press, SS up, which sends a key release, and SS delay, which will delay for the specific number of milliseconds that you define. To add a bit of fun to the equation, key codes now start with X underscore instead of KC underscore. But if you want to modify a key, you don't use left shift and the key like you do with the normal layout, but SS left shift and the key. To configure a macro that does command left arrow / H1 enter command right arrow, I need this string of code. And you need to do that for every macro you want to create. Name it, define it, add to your layout, repeat. With our configurator software, Bazecor, I can create that macro with the UI without worrying about not closing a parenthesis and getting a compilation error. Nonetheless, the crown of all efforts has been adding per key RGB. I literally lost the little hair I had left on my head getting per key RGB to work on this keyboard. But before sharing my quest, please let me show you how easy it is to assign per key RGB to my DeFi keyboard. I open Bazecor, select the color, assign it to my keys, and press save. That's it. Now, let's try to create a similar per key RGB on the Unicorn. My first attempt was trying to read the QMK documentation on custom RGB effects. I've dabbled in HTML, CSS, and PHP, but understood nothing of the documentation. It would have been written in Klingon for all I care. I've shared the link in the description for those of you who feel brave today. So I did what any vibe coder would do. I asked ChatGPT. Again, I kid you not, I spent a whole day going back and forth without any meaningful success other than learning all the compilation errors imaginable. To be fair, at some point I got some LEDs to change to what I wanted, but the keyboard froze constantly when switching layers, and the fixes suggested by ChatGPT somehow made it even worse. So I let my failure rest for a week or two, and after asking around, I decided to give it another go. This time using Cursor, which has integrated AI that can directly change the code for you. If that's not vibe coding, what is? This time I got it to work. Yay! Finally! Now I have custom colors where I change layers. Here are my arrows. This is my number layer, and this is my symbols layer where I have all my symbols. My macros are here. But let me tell you, it was not easy. These are some of the compilation errors I got. I defined some color names in the keymap, but those were already defined in the QMK colors H file, and you can't redefine them. Compilation error. My keyboard has 42 keys, but for some reason there are 54 LED positions. Compilation error. I misspell a color. Compilation error. I defined the same position twice. Compilation error. I breathe too heavy. Compilation error. And that's not all. Once I got the firmware to compile, my LEDs were out of place. No. It turns out that a maniac designed the LED positions. They don't follow a straight pattern, like 1, 2, 3, 4, 5, 6. No. They zigzag through the keyboard, starting here on position 7, and then skipping positions 27 to 32 to start here on position 33. I had to assign random colors to find out that pattern. It was very fun. I felt like Alan Turing deciphering Enigma. In the end, I figured it out and was able to prepare myself a very professional cheat sheet of where each LED is. Very professional. To top it all, if I assign too many custom LEDs to a layer, the keyboard froze when switching to that layer. I'm sure there's a way to fix that, but even the AI gave up and simply recommended that I be more resource sensitive and use fewer custom colors. Let me say that again. The AI gave up.
Hasta la vista, baby.
So, instead of defining a color for each key, I ended up with a base color for each layer and some custom colors for specific keys. Here is all the code that defines the colors for each layer. Somehow, I have memorized the keys position and I can see the layout and the colors in the code.
All I see is blonde, brunette, redhead.
You'd think this would be the end of it, but I feel like I've just scratched the surface. And that's the beauty of QMK. There are a gazillion options. You can configure in detail how mode tab and layer tab keys behave. You can even have different parameters for different keys. Just look at the documentation. It goes on and on explaining all the options just for mode tab and layer tab. You can also create combo keys, which trigger a third key when you press two keys simultaneously. For example, if I press G and X, I log to my numbers layer, and many more things. However, I don't think the effort is worth the benefits. Over the past months, I have spent countless days getting this QMK keyboard to behave like my Dygma D5. I've had to try 4 different tools, install a development environment, learn how to use the terminal to compile the firmware, figure out how to program the layout in C, and search over and over again how to do things. I've lost count of how often I felt frustrated and gave up. And I don't give up easily. I learned Ngram. Setting up the same configuration on a Dygma keyboard would have taken a morning, maybe a day, tops, if you didn't know what can and can't be done. Yes, maybe some features are missing, like super fine tuning of mod tabs, combo keys, auto shift, or caps work, but most users will not get past the very limited VIA options. Maybe the QMK configurator at most. I really don't see a normal user configuring a development environment to be able to flash QMK Vial to their keyboard, let alone code their keymap in C or configure advanced features like a custom RGB effect. I think that's what people often overlook when they recommend a DIY QMK keyboard. It can be cheaper, it has a lot of potential, and it can even be very rewarding. But tapping into that potential is an arduous journey that's not usually mentioned. Maybe there's some bias because once you learn to do something, it feels much easier. But that's just my 2 cents after trying a DIY QMK keyboard for a year. We love to hear your opinion. Have you tried a DIY QMK keyboard? Do you like it? How do you configure it? Do you use VIA, QMK Configurator, or do you code it yourself? We want to know everything, so please leave your comment below. Ciao!